When he showed up at a top university, they handed him a degree and the professors came to him to seek answers. He fasts for 1 week straight at a time, so that cows don't go extinct. His equipment has traveled underneath El Chapo's jail cell and through Gaddafi's pipeline under the Sahara, supplying water to an entire nation. He designed the world's first free-swimming ultrasonic pipeline robot, but he's blind as a bat. He's thought about crossing the Gobi Desert in his Forerunner. Twice. He is the most disheveled engineer in the world.
I don't always drink water, but when I do, I prefer to implode my bottles. Let's go.
Hello. Today we're going to take two of the most popular and most expensive water bottles on the market, and we're going to put them head to head. But instead of your standard ice cube thermal insulation test or throw a bottle off of a 10-story building impact test, we're going to do something new that's never been done before. We're going to implode both bottles to see which is the strongest. And then just for kicks afterwards, we're going to slice it down the middle to see how the engineers designed it on the inside. I know the folks at Hydro Flask and Yeti won't be pleased, but I paid top dollars for these and I intend to squeeze every cent out of it, quite literally.
In the spirit of fairness, I've selected two bottles with the same capacity and color, with more or less the same price. They're both designed in the USA, although one is designed in Texas and the other in Oregon. But guess where it's made? Yep.
Now these bottles are brand new, and in order to keep it a fair comparison, we're going to use this torque wrench to tighten both lids to the same torque.
I'll also need 1/2-inch adapters to mate onto the lids, so I've gone ahead and 3D printed these parts for both bottles. To figure out the torque we need, we're going to snoop around NASA's website under Human Performance Capabilities and scroll down to torque strength. The maximum torque supination, that is the rotation outwards, is 13.73 Newton meters, which is the number we need since we're tightening the bottle clockwise. If we convert the number to foot-pounds, we get 10.1. So let's set the wrench. Alright, I guess we'll go with this first. I was actually expecting the bottle to fill up with water right away, but it held up much longer than expected. You can see the bottle started buckling here at 27 meters, but the seal only begins leaking at 261 meters. And the bottle completely fills up with the water at 2.6 kilometers deep in the midnight zone, which is quite impressive. Let's review the video. We can see that the bottle structure fails at 27 meters, and the seal at the lip begins leaking here at 261 meters. But I want to fast forward to the end because something very interesting happened. During the depressurization, the internal water pressure inside the bottle, which went up to 5,000 psi, began to stream out past the seal. For some reason, the bottle appeared to be smoking, which seemed odd. I thought it was a delaminated liner, but it isn't an aluminum bottle with a microplastic liner, and according to Hydro Flask, there is no liner. If anybody has any idea as to what this cloud is, please comment down below because I have no clue. Let's move on.
As much as it pains my wife and you Yeti fanboys out there to see this Rambler get utterly destroyed, the show must go on. By the way, it probably goes without saying, but please don't try this at home. I'm a professional and this isn't your run-of-the-mill pressure cooker.
Looking at the pressure log data, the Yeti begins buckling at 79 meters, which is deeper than the Hydro Flask. But the seal failed and the bottle filled up sooner at 130 meters. This is because it uses gasket-type seals rather than an O-ring seal that's used on the Hydro Flask. The opening on the Yeti is also larger. Let's slow down the acoustics again, right where the bottle buckles, for all you audiophiles out there. Alright, I promised to slice these up, so please stand by. Now, time for the big reveal. Let's start with the Yeti. We can see right away the double-walled construction and the secret to Yeti's thermal insulating performance that you paid for. It's literally nothing. Well, right now it's filled with air molecules, but before there was a vacuum inside, which eliminates heat transfer by conduction across the wall. And yeah, since it's a vacuum, there's nothing to conduct the heat. There is heat conduction along the wall, but that's to travel a longer path, so it's slower. You can see the inside layer is actually copper plated. This is to reduce heat transfer from radiation by reflecting heat energy back inwards. All these features help to keep your coffee hot on your way to work, which is pretty cool. Now let's look at the Hydro Flask. This bottle has a similar construction as the Yeti with the stainless steel body and vacuum interior. But this one is completely collapsed like a cheap suit because it was able to maintain the seal longer and the outer wall didn't rupture as it did on the Yeti, which you can see right here. This is why the double wall didn't collapse on the Yeti, but it did on the Hydro Flask. The seal broke at the opening where it deformed. Let's see which one has the thicker wall. .62 millimeters on the Yeti. .54 on the Hydro Flask. So the Yeti has a thicker wall. Honestly, with the amount of steel in these bottles, these companies are literally printing money with all the cash flowing in from all the soccer moms in yogis gobbling these up. In fact, let's figure out the raw material input cost for each bottle right now. $365 grams. So that's about 55 cents US for the Yeti. Going with the 304 stainless steel sheet prices in China. And 246 grams for the Hydro Flask, which is about 37 cents worth of steel. Stainless steel, that is. Of course, there's other costs as well, but these things are just whipping out of the factories.
Here are the results for today's test. It looks like the Yeti came out on top when it comes to strength, with the bottle reaching nearly 3 times the depth of the Hydro Flask before the metal begins yielding. It makes sense since it has a thicker wall and a heavier build. When handling both bottles, it does feel like the Yeti is stiffer and more solid. I'm still curious as to what the cloud was from the Hydro Flask. All I did was remove the paperwork on the inside and close it back up. Maybe I was supposed to rinse it before use or something.
Disclaimer. Unless the substance that ejected out is sent out for testing, we do not know for certain what the mysterious cloud is. An independent ISO-certified lab analysis of the sample is beyond the scope and budget that was originally intended for this episode. We are not affiliated with Yeti and this segment was not sponsored by them. This content was made for entertainment purposes only. Please don't sue.
Okay, time for some giveaways. For all you modern art collectors out there, I have this one-of-one signed imploded Yeti bottle and Hydro Flask bottle. I haven't gotten these appraised yet, but I'm pretty sure they're worth something because I won't be imploding these again. Type in first dips for the Yeti and second dips for the Hydro Flask below, and I'll send them out. If you guys are new to this type of imploding content, please consider hitting the subscribe button so you guys don't miss out, just like you did. And if you guys still need to quench your thirst, I have some beer on tap. I have Corona and Bud Light. Yeah.